Do you remember that a solution is a homogeneous mixture? When you think about solutions, you usually think of solids like Kool-Aid powder dissolved in water. A solution's concentration is a measurement of how much solid is dissolved in a given amount of water. Only a small amount of solid is present in a dilute solution. A concentrated solution, on the other hand, contains a considerable amount of solid. The molarity of a solution can be used to determine its concentration. So what exactly is molarity? Molarity is defined as the moles of a solute per liter of a solution. The molar concentration of a solution is also known as molarity. Hi everyone, we're back with another laboratory exercise. This time, demonstrating the preparation of solutions from solids with an emphasis on the sodium bicarbonate solution. Have you ever been curious about what really happens when you mix baking soda and water? The chemical compound sodium bicarbonate, sometimes known as baking soda or bicarbonate of soda, has the formula. Sodium bicarbonate is a crystalline white substance that frequently appears as a fine powder. When baking soda reacts with water, it produces heat and carbonic acid. An exothermic reaction rather than an endothermic reaction is the name given to this sort of heat, because an endothermic reaction requires the addition of heat to initiate the reaction. When there is an excess of heat, exothermic reactions occur. As a result, it is an exothermic process because no heat is transferred to the water. The carbonic acid is no longer stable at this point. This is when the well-known fizziness enters the picture. Carbon dioxide is generated when baking soda combines with water, resulting in the iconic fizz. Now, let us begin our activity of drawing conclusions concerning the sodium bicarbonate solution without more delay.
So, we have here the materials we use. Procedure. First step is to weigh out on a clean, dry, and clear glass container exactly 10 grams of solid sodium bicarbonate, also known as the baking soda. Transfer the 10 grams of sodium bicarbonate into a 25 ml cup. And add 10 ml of distilled water. Add it on a 25 ml cup. And stir. We transfer the entire solution into a measuring cup, so we will be able to measure it. We rinse the 25 ml container twice with 1 ml portion of distilled water and add it in a measuring cup. And stir the solution. We add more distilled water in the solution until the 25 ml mark is reached.
This is the sodium bicarbonate solution. What is the molarity of the solution? So, in 1 gram, there are 0.011903825158789 mole. In 10 grams of sodium bicarbonate, we have to times it into 0.011093825158789. So times 10, it is equal to 0.11903851. So this is the value of the moles of solute. So we have here the formula of molarity is equal to moles of solute over liter of solution. So molarity is equal to, so the value of moles of solute is equal to 0.11903851 over liter of solute, which is the 25 ml. So divide that one molarity is equal to 4.7615404 times 10 to the negative 3 power m. What is the normality of the solution? We have here the formula of normality is equal to number of gram equivalents of solute over volume of solution. So normality, we have to substitute the 84.01 gram per mole, which is the molecular weight of sodium bicarbonate, over 25 ml of the sodium bicarbonate solution. So divide that to 84.01 gram per mole divided by 25 ml. We have here the normality is equal to 3.3604 n.
Compare the way your group express concentration to the way other groups express concentration. The way our group expressed in the concentration and other group is somewhat the same, due to the fact that each group need to find the morality and normality of its different solutions that are being assigned to. One of the most commonly used methods for expressing the concentration is molarity. It is the number of moles of solute dissolved in 1 liter of a solution. Number 4. Did each group express concentration in the same way? Each group somehow express concentration in the same way in which they measure each of how much of a given substance there is mixed with another substance. Usually, this means there is a lot of a solute dissolved in a given solvent. A concentrated solution contains the maximum amount of solute that can be dissolved. A dilute solution means the quantity of solute is relatively very small. On the other hand, a concentrated solution implies that the solution has a large amount of solute. Number 5. How did each group come up with their system? The way each group come up with their system is that they follow the procedures that are given and the process that need to be done in order to come up with a result. When we say system, it is the set of substance and energy that is being studied. The system consists of those molecules which are reacting or in a formal model of interactions between biochemical reactions.
What is the purpose of Activity 1, the preparation of solids from liquids by sodium bicarbonate solution? The purpose of this preparation of solids from liquid is to know the reactant of the sodium bicarbonate solution, also known as baking soda, to the distilled water, and how to put together solution in distilled water to make a solid from liquid. Make a solution with the necessary number of moles of solute in enough to solvent to give the desired final volume of solution. To make a solution with a given concentration of material. Then, the dilution of solution of sodium bicarbonate solution reactant by the solid from the liquid reaction.
Conclusion. As we all know, a solution is a homogeneous mixture of two or more substances. It has two parts, which is the solute and the solvent. So the solute is the substance that will be dissolved in the solvent, while the solution can be categorized based on the components mentioned. So in this experiment, when a substance dissolved in water, it reveals information about its composition. In other words, it indicates that the substance that the water is tugging on has a charges or partial charges. And in this laboratory, we learned that the molarity of a solution may be determined by looking at it. The intensity of a color increases as the molarity of a solution grows, and the molarity of a solution drops, the color intensity decreases. We can also deduce that the solution can be diluted by increasing the solvent concentration to reduce the molarity. And also, in conclusion to this experiment, was really beneficial in learning the procedures for producing solutions with specific concentration. So this laboratory experiment involved weighing a precise amount of dry material and measuring a precise amount of liquid. However, preparing solutions accurately will improve an experiment's safety and chances of success.